Now we are going to use the Azure Machine Learning Studio on German credit data. So basically here we are going to develop the predictive model for a credit risk, but initially the database which we are going to use, it's not available in the Azure Machine Learning Studio. So we'll go also in the UCA Machine Learning repository, and we have downloaded the dataset from here. So the dataset normally contains the number of instances, means the rows is 1000 and attributes is 20. That means the columns are 20 here. And the German dataset I have downloaded here, which basically I am showing you. This is the dataset, and which has the 700 applicants which identify as a row credit rates, and the remaining 300 are identified as a high credit risk. But there is one interesting twist. The description of the dataset at the website mentioned, what if the cost which classify a person of a credit risk if the model predicts a high risk for someone who is actually a low risk, and if the model has made a misclassification, we would say, but the reverse misclassification is 5 times more costly to the financial institution. If the model predicts a low risk of someone who is actually a high credit risk, so we want to train our model so that the cost of this later types of misclassification is 5 times higher than the misclassifying on the another way. That how we can remove this misclassification, I will show you later on. So first of all, our data which we have downloaded here, which was not in the Excel or a CSV format, so I have converted that data set into the .csv file using the PowerShell here. And now the this data set is available on our local machine, right? So to download to upload the data set to the machine learning studio here, we need to click on this plus new button, and then we need to go into the dataset, and from the local file we can choose our dataset which is already available on our local system. So here we can give all the information about the dataset, what is the name and what is the type of the dataset, and we have created the options here. I have already uploaded the dataset which we can see here in the dataset options. So I have given the name as the UCA German credit data, and the submitted by also it shows the name. If the multiple team members are working on that, then it would be better if we give the submitted by information also. And there is the description in which we have added the URL. And now we are going to start our experiment here. To create the experiment, just we need to click on this plus new button, and we need to glow in the experiment as we did in the first part. And we need to click on this +1 blank experiment. I have already created the experiment which I will show you here. If we go in the credit risk experiment here, then you can see in the first part on the right side of the panel I have added the summary and the description also, so that would be beneficial for the user to identify like what's the exact summary and what we are going to achieve. Like I added this experiment predicts the credit risk, and the training was delivered here, and we have downloaded the repository from the UCA catalog dataset, and all the information we can see here. But the main challenge is like we don't have the headers also. That while uploading the dataset, I have already selected the no header value. Okay, I will show you again. Like if we go in the dataset part, and here you can see here generic CSV with a no header, and by default it will assign the values as column 1, column 2 and everything. So how we can utilize the dataset? If we go in the my dataset, I have uploaded this UCA dataset from my local file, so that will be available here. So I have just dragged and dropped this dataset over here, and if we open this, then it will be visible. Like if we open this visualize tab, we'll able to see that by default it have given the column 1 to column 20 to 21 now, as there are no column name. But it would be beneficial if we have the column names, just to identify that would be make easier for us, like while we are working. That would be if we assign any such name. So the next step would be we will use the metadata, edit metadata. I would try to add the comment section also for each and every model in the canvas, so that would be easier to identify. So in the edit metadata, um, if you open the launch column selector, we have added all the columns here from column 1 to column 21, and we have assigned like no column names, or in the new column names we have added the tags, all the tags available. So once we run this, it will be this tags will be given to each and every column in the sequence wise, right? So if after we run this, if we add the dataset in the visualize tab, we will be able to see like the column 1 to column 21 is removed, and instead of that it has assigned each and every value to its column name. So the edit metadata part is completely successfully executed. Now the our next target is to like yeah, definitely first we need to disconnect the usage element data, edit metadata, and after that only we can perform all these required steps. Now the main part of the machine learning, initially I tried with the 70-30 ratio, and then in the comment section I entered the 70-30, but right now and after that I changed the percentage and to the testing on the training data, and then I did it the 55 50-50. The fraction percentage we can see in the right side of this, I added the 0.5, so 0.5 will be utilized for the training, and 0.5 will 50% will be the testing side. So I tried with the both 70-30 and the 0.5. 70-30 works well, but for the execution I have added this. Now the main part comes here, the execution of the R script. So why we use the execute the R script? So initially I have introduced there are some misclassification. If we classify the low risk to the high risk and the vice versa, that would be the big loss for the organization, especially the financial organization. So that's why execute R risk module comes into the picture. So we have added the execute R script module in our canvas, and we have added this R script here. Using this we can see like the execute R scripts properties in our dataset to avoid that misclassification in our data. So I have just execute our script two times, just one is for the training data and another one is for the test data, and will split. Initially we are splitting the data, so 50% for the training and 50% of the test of the data, and then the main part comes into the picture to like to which machine learning module we are going to use, right? So to train the multiple modules are available, like we there are multiple modules are available in this machine learning studio. So here here we are going to use the basically main two part like support vector machine SVM and the boosted decision tree. Here we need to predict the credit score. To prediction of the credit source, the SVM is the best tool, and another one is for the decision tree. So we will compare the result of both of this module, and then we'll identify like which for which module we can proceed further. So I will show you first the boosted decision tree part. So from the left of the experiment item, we will add the boosted decision tree here, and the boosted decision tree, and the boosted decision tree with will train our module. So we'll expand this. We'll able to see once we click on the launch column selector. We need to identify basically a credit risk. So we have added the credit risk in our train of the module example, and then here in the selected column also we have selected the credit risk. It will be easily visible, and now we need to scope of the we need to identify the score of the model. That's why we have added the score model here, but the for score model we need to utilize the test data also. So test data we have also added here. This already executed, so we can directly see the result here in the panel bar. You can see the score probabilities are available, and these are the actual result, and this probabilities which we have predicted. And similarly we will utilize the support vector machine. So why exactly we are using here? The booster decision tree normally works well with all the feature of any type, right? But the support vector machine module which generates a linear classifier, and the model that generates have a best test error when all the numeric features are on the same scale. But we don't have the numeric feature are on the same scale. So what we are using is we will use the normalized data. But to first of all, we'll use the in the normalized data we'll use the 10H for the transformation. There are various transformation methods are available. So here we are using the 10H as a transformation method. So our transformation number will change to the either binary feature like 0 or 1. So we no need to manually transform the data as our data set is too large, right? Now the it's numeric, but the value we are training to predict, we need to leave it alone, right? So first of all, we'll take cursor and we will drag and drop the support vector machine here, and the normalized data we are using, one is for the testing and another one is for the training. We have just copy pasted this normalized data, so the same feature will be available on this normalized data also. This, as you can see, the 10H is also available, and then all the yeah, and one more thing is like all the numeric column here. Whenever we add the numeric data, we want all the numeric column, but they excluded the credit risk because we want to identify like what is the exact credit risk, so we have excluded here. And same as previously we done, we will identify the score of the model and we will execute it. Now to evaluate like which model is better, if we identify the support vector machine scores, then in the visualize panel it will again show the predicted output with the score probabilities. And now once we evaluate the model, we'll evaluate both of the models, right? And then we'll evaluate the result. So once we click on this evaluation button, we'll see the comparison of the score dataset and the score dataset to compare. So SVN and the booster decision tree, we'll able to see the output of both of the models, the ROC, then the precision and the recall and the lift, all the values will be available here. Now once we go down here, the ROC is basically a receiver opter. ROC is basically is the receiver opter characteristics, and the precision, recall and the lift, which I already told you. Additional data includes the confusion matrix, cumulative values and many more. So once you go down, the true positive value, accuracy, precision, the precision is good for this model here. And we can evaluate the other features also, like how many positive and the how many positive values and how many the true positive and the false negative and everything. So once we if we want to see the output of the other data set, we just need to click on this earth, and this will be highlighted in the bold, and then we can compare it. So we can identify like this which one data set is giving the good accuracy. So this is going F1 score, and the recall and the precision is going to the 70.3%, right? So according to this, we have identified like this the the decision tree is giving the better result as compared to the SVN. So now to work on the only one part of the model, will remove the another one. So initially what we'll do, we'll remove all this, we'll remove the another model, and then I have already removed it, so I will show you directly that one. So initially, first of all, we need to remove this additional machine learning model which we have added, and then we need to execute all the script, and then on the setup side, predictive web services, which is a recommended one, we have to execute it for the deployment. So I will show you. Already I have worked on the predictive experiment. So once we deploy on the web services, the data will be converted to the two class boosted decision tree train model, and the splitted data which is available here in the training experiment will be converted into the UCI German credit data and the UC web services input. This web services input, and this will another output will be shown as a web services output, right? So after this, the deployment of the web services will be done. Just to deploy web services, I have already deployed it, so I will click on this no button, and go to the web services URL is already present. So actually we can do the deployment by the two ways there are for the deployment. One is the classic web services, and another one is the new web services. So once we go in the new deployment, now there are two options. One is the dashboard, and another one is a configuration. So we have done the classic web services, and if we click on the snapshot and the latest, it will again redirect to the page where we have created here, and the configuration here. We can modify the service name, and we can give the description over here also in the configuration tabs, right? And if we here we can see the all the column here, the column 1 to column 22, and with its data type, and the new assigned values which we have given in the metadata will be present here. And if you want to test something when the service is accessed, the user data enters through the service dashboard. We can go to the dashboard, and we will click on this test button. So here we can enter the data whatever we want to predict, whether the credit risk is high or low. So using this, and once we run this, we can predict the output of the dashboard. So this is using how we can test this data. So we have included from the uploadation of the database to the creation, splitting, and the deployment, machine learning model training to the deployment. All these steps are included in these steps. So, thank you.